So we're going to be looking at the study guide for Chapter 6, which is all on transformations of figures and points. So let's get started. So basically the first few questions are just going to consist of your basic transformations and applying them as they should be. So here we have the original coordinates A, B, and C, and it says we want to translate 7 right and 3 down. So with translations, you have to remember that right is controlled by the x coordinate, and down is controlled by the y coordinate. So the x controls the right and left movement, the y controls the up and down movement. Let's go ahead and rewrite our points here just to make them a little bit easier to manage. So negative 2 comma 7. B here would be 3 comma negative 5. And then we have C here, which is negative 11 comma 7. So if we're going to move 7 right and 3 down, that means 7 right, well, right is a positive direction. If you think on the graph, if you go right, you're in the positive x numbers here. So I'm going to add 7 to all my x's. And 3 down. Well, down is a negative direction on the y-axis. So I'm going to subtract 3 from all my y's. Down is a negative direction, right is a positive direction. Thus the difference between adding and subtracting. And then you just do some quick mental math here. So 7 plus negative 2, or negative 2 plus 7, however you want to say it, gives you 5. 7 minus 3 gives you 4. That'd be A prime. B prime would be 10, and then negative 8. And then C prime would be negative 4, positive 4. And then that will be your final answer. Again, your final answer is just going to consist of the 3 points after they've been moved. So for translations, again, remember that right is a positive x, left is a negative x, up is a positive y, down is a negative y. So pay attention to not only the number, but what direction you're moving, and make sure that you apply it to the right coordinate. So 7 units right means add 7 to the x's, 3 units down means subtract 3 to the y's. And just do the same thing to each point. The next one here is on rotation. Rotations are a little bit trickier. Let's go ahead and again rewrite our points here just so we can do it all at once rather than try and do it one at a time. So negative 6, 3. B here is 4, negative 7. And C here is negative 2, negative 8. So if you're going to rotate 90 degrees clockwise, rotations usually consist of 2 steps. Multiply one of them by negative 1, as in one of the coordinates, and then switch the coordinates. There's only one rotation that doesn't switch, and we'll talk about that later. But 90 degrees clockwise, the question is, am I going to multiply the x or the y by negative 1? Well, the way you can tell is you can draw a quick graph and draw a little arrow kind of going off to the upper right corner there. And think of it as a clock. If you're going to go clockwise, which means you're going to go this way, if you're going to go clockwise, that means you're going towards the x-axis first. That means you're going to multiply your x's. All your x's get multiplied by negative 1. If you're doing counterclockwise, you'd be going the other direction, and you'd be going towards the y-axis first, and therefore you multiply your y-coordinates by negative 1. And then after we multiply by negative 1, we're going to swap the positions of both coordinates. So swap the positions there and there, swap the positions there and there. So we end up with A prime, which is 3 comma 6. Again, positive 6 because negative 6 times negative 1 is positive 6, and the 3 just comes. Here it ends up being negative 7, negative 4. And then here it ends up being 8, 2. Again, negative 2 times negative 1 is positive 2. Bring the negative 8 across. Sorry, my bad. And then 4 times negative 1 is negative 4, and then bring the negative 7 across. So again, clockwise means multiply your x by negative 1 and then flip the numbers. Counterclockwise would multiply your y by negative 1 and then flip the numbers. And the way you can keep that straight is imagining it like a clock on the graph. If you go clockwise, you're going towards the x-axis first. If you're going counterclockwise, you're going towards the y-axis first. Excuse me. So the next one here is a dilation. Dilations are probably the easiest one. All you do is you multiply. So we're going to take our coordinates A, B, and C. So negative 5, negative 9. B, which is 3, 2. And C, which is negative 8, negative 7, negative 8. Sorry, should probably say that in order. So dilate by a factor of 0.8 means all we're going to do is take each number and times it by 0.8. So times by 0.8 times by 0.8 times by 0.8 and all the way down the line. 0.8, 0.8. And so what we end up with here is our new sets of coordinates. So just bring up my calculator here, just make sure I don't do any math wrong. So negative 5, whoops, turn it on first. Negative 5 times 0.8 ends up giving me negative 4. And then we do negative 9 times 0.8. That would give me negative 7.2. 3 times 0.8. So 3 times 0.8 would give me 2.4, I believe. Just making sure I'm right. Yeah, there you go. And then 2 times 0.8 would give me 1.6. And then we do the rest of it. So negative 7 times 0.8 would give me negative 5.6, right? And then negative 8 times 0.8 would give me negative 6.4. And then that's it. That's A prime, B prime, and C prime. Again, showing your work is always good. That way, if you do something wrong, your teacher can give you partial credit. But dilations only require you to multiply the x and y by the same number, not by different numbers, not by switching signs, not by switching numbers, but just take the scale factor and multiply it to everything in the points. And then this one here is asking us to reflect over the main diagonal. So reflections usually require you to multiply one of the numbers by negative 1 and then leave it alone. Like reflection over the y means multiply your x by negative 1 and then leave it alone. Just bring down your y coordinate and be done with it. Reflection over the main diagonal is the only one where you don't multiply. So if I have my points here, let's just write down 3, comma 0, 6, comma negative 2, and c, comma 9, 9. Reflection of the main diagonal means you're going to take your x, y coordinate and you're going to swap them like that. That's all you do for a reflection of the main diagonal is you just swap x and y. So this becomes 0, 3, and that's A prime. This becomes negative 2, 6, and that's B prime. This becomes 9, 9 still, and that's C prime. So C prime doesn't change. But that's all you do for reflection over the main diagonal is you simply swap the numbers and then you're done. Reflection over the x or y axis requires you to multiply by negative 1 and then not swap, but I'll talk about those a little later too. But as far as this one goes, all you need to do is swap the numbers and you're fine. So the last little bits we have here are compound or composed transformations. So we have triangle ABC here, and we want to perform these transformations on it. So we want to rotate, reflect over the x, and then translate. So it's important that you do the transformations in sequence. If you don't do them in sequence, then you're not going to get the right answer. And that should say rotate. That's a misspelling. You have to forgive me. So let's see how this goes here. So we first want to rotate 270 degrees counterclockwise. So here's the thing about 270 degrees. If you rotate 270 degrees one direction, it's basically rotating 90 degrees in the opposite direction. So 270 degrees counterclockwise is the same as 90 degrees clockwise. And 90 degrees clockwise means you're going to take your x and y number, and you're going to multiply the x by negative 1, and then swap the numbers. So it would look like this. So you go from xy to y negative x. So that means here, if I apply that same idea, take your x number, multiply it by negative 1. So multiply all your x's by negative 1. And then swap them. So this would be 6, negative 1. This would be 1, negative 5. And this would be 4, 2. So those would be my first transformation. Okay, those are the rotations. Reflect over the x is also another negative 1, 1. So reflect over the x. If you're reflecting over the x-axis, that means you're folding from top to bottom. So here's my x-axis. If I'm reflecting over that, that means I'm taking the top graph and folding it down to the bottom, or vice versa, taking the bottom graph and folding it up to the top. So because my fold is in the up or down direction, that means I'm going to multiply my y numbers by negative 1. So if you reflect over the x, you're going to multiply your y numbers instead. So I'm going to take all my y numbers and multiply them by negative 1. Got a little bit of hiccups there. And again, the way you can tell that you're multiplying the y, not the x, even though it says x-axis, is kind of think about how that would look. So if this is my point A, let's say I do a separate problem here, and I want to reflect it over the x-axis, I have to move it down to get across the x-axis, because reflecting it means that it should go from here down here somewhere. It's kind of like looking in a mirror. So I have to go down from the point, not left and right. So if you're reflecting over the x or y axis, you multiply the opposite coordinate by -1. And then we rewrite our point. So no switching involved with this reflection here. So 6, +1, 1, +5, and 4, -2. So that one's done. And the last one is translate 3 left and 2 up. So again, remember that translations, left is a negative direction, and it's a negative on the x. So we're going to -3 on the x, 2 up. Up is the positive direction, and it's on the y. So we're going to add 2 to my y's. So subtract 3, add 2, subtract 3, add 2, subtract 3, add 2. And we write them down here. So 6 minus 3 is 3, 1 plus 2 is 3. 1 minus 3 is -2, 5 plus 2 is 7. And then 4 minus 3 is 1, and then -2 plus 2 is 0. So that'd be C triple prime, B triple prime, and A triple prime. The reason they're triple prime is because we did 3 transformations on them. So if you want a graph to see how this end up, we can. So like -2, 7, that would be somewhere right there. So that'd be my B triple prime. C would be 1, 0, so that'd be right there. That's C triple prime. And then A would be 3, 3, so 1, 2, 3, 1, 2, 3. So A prime, prime, prime would be right there. And so my triangle ends up doing something, whoops, let me try to get that better there. My triangle ends up doing something like this. Okay. Try to erase that erroneous line there. There we go. So I end up with this sort of triangle here, which again kind of sounds like it's been rotated and reflected and translated. So it looks kind of like the part there. But again, you can use the graph to help you figure out whether your shape is looking good or whether you like one point's way off. A lot of you have found that when you start graphing stuff, if like this point was like way over here, then you notice something was off and you go back and check your work and probably find what you missed. So the last type of question we have is basically on symmetry. So remember we talked about 2 types of symmetry: rotational symmetry and line symmetry. Rotational symmetry is simply when you have a shape that can be mapped onto itself by using a rotation. And it's usually a rotation between 0 and 360. Because obviously if you rotate 0 or 360, it's always going to map to itself. But this rotation has to be between 0 and 360. So for example, a star like this, again, imagine if this was drawn perfectly, okay? A star like this would have rotational symmetry. If I spin it, this point would go there, 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 and it'd still look like a star. So I can turn it between 0 and 360 degrees and have it match onto itself, to have it overlap itself, essentially. So rotational symmetry requires a rotation between 0 and 360. Line symmetry is not necessarily the opposite, but line symmetry is when you have symmetry that a shape can be mapped onto itself using a reflection. So for instance, the shape this right here, again, best I can draw it here, this little fancy arrow, that would be a reflectional symmetry shape because the line right here can serve as a reflection zone. So I can take the top part, reflect it over that middle line, and have it map perfectly on the bottom part, assuming I can draw perfectly. So reflections are when you can fold shapes together and they match perfectly, which is called mapping to itself. That's a shape that has line symmetry, whereas rotational symmetry is when you can turn a shape and have it match onto itself, which is why it uses a rotation. So that's all for the study guide there. Before we close though, there's one extra thing I want to recap real quick, and that's just kind of a general overview because there's lots of different small little rules and formulas to remember here. So I just want to quickly briefly go over the overall outline for those that might still need a little bit more attentive to detail. So the first thing, translations. Again, translations deal with adding. Left and right, you add to the x, and up and down, you add to the y. So translate 3, -4 by 7, -3. All we do is we add first to first. This would be +7, and then add second to second. So it would be plus -3. So that would be 10, comma, -7. Again, 7 right, which means add the 7, and 3 down, which means add the -3. So translations deal with adding numbers to the coordinates. Reflections deal with multiplying by -1 in most cases, unless you do the main diagonal. So reflection over the x, which means basically you have a shape like this, and you reflect it over the x by folding it from top to bottom. That'd be reflection over the x. You multiply the y coordinate by -1. So 1, 2, you're going to multiply the y by -1, and you get 1, -2. That's how you reflect over the x-axis. For the y-axis, that's like this here, where if I have sort of this shape here and it's reflected over the y, it ends up being like that. In this case, you're going to do the same thing, but to the x. So you multiply the x by -1, and in this case, I would get -2, 3. So there's no adding or subtracting involved. It's just simply multiplying one piece by -1 and then leaving the other one alone. The only reflection you don't multiply by -1 with, and the only one that you do swap coordinates for, is the main diagonal. So for a main diagonal reflection, what you do is you take these points and you switch their positions, and you get this as 5, -4, and then you leave it. There's no multiplying by -1, no fancy extra steps or anything. Just swap them and leave them. So for 90 degrees rotation clockwise or 270 degrees counterclockwise, so these are both the same way. Going 90 degrees this way and going 270 degrees the other way is the same movement, same rotation. It's basically a combination of the main diagonal and the reflection. So you multiply x by -1 and then swap them. So my x number gets multiplied by -1, and then I'm going to swap positions. So it'd be -2, -3. So multiply x by -1 and then swap. Please do this before you swap, otherwise you're going to multiply the wrong one by -1 and miss out on some points there. For the other direction, 90 degrees counterclockwise or 270 degrees clockwise, you simply do the same thing but with the y. So you multiply the y by -1, and then you swap them. So it'd be -7, 5. The way I remember the difference between these two is, again, I look at kind of like a graph and think of it as a clock with the hour hand or whatever starting at the upper right-hand corner. If I'm going clockwise, which is this way here, I'm going towards the x-axis, so I have to multiply the x-axis first. Whereas if I was going counterclockwise, you have to multiply the y-axis first because that's where you're heading to first. And then 180 is a special kind of rotation, and then you don't swap. All you do is you take both numbers and multiply them by -1. That's it. So, and this ends up being 6, -8. You do not swap the numbers in a rotation of 180. So people often forget about the fact that a 180-degree rotation and a main diagonal reflection are the oddballs in their group. So for reflections, everything deals with multiplying by -1, except for the main diagonal, which only deals with swapping. For rotation, everything hinges upon multiplying by -1 and then swapping, whereas 180 is simply multiply both by -1 and don't swap. So 180-degree rotation and main diagonal reflection are the ones that you want to be careful of because they are the most commonly missed. And then lastly, for dilations, again, probably the easiest of the bunch, all you do is you simply take your scale factor and you times it to both numbers. So times 1.2 times 1.2. And in this case here, we get 8 times 1.2. Whoops, that's 12. Let's try that again. 1.2 gives me 9.6. And then we have -3 times 1.2